All right, guys, I'm going to do a quick rundown on how we're going to do problems digitally. That was hard to say. All right, so we're going to use this platform, and how I'm gonna do it is you'll have slides. So slide one, I kind of skipped over, was just a quick introduction. Make sure you can write on the slide. There's tools up at the top where that you can use to change to change the type of pen, to change the color, that kind of thing. So this one's kind of just a quick little intro, and then you're going to once you have that done, in the upper right hand corner, you're going to hit it's an outline of a hand. You hit the green hand, and it'll submit it, and then that'll indicate to me that you need it checked. And then over here, how I'm gonna check them is with these stickers. You're looking for a 10 out of 10, so exceeds expectations. That's your goal. Let's just say hypothetically you're close. The problem's close. You maybe have the answer right, but you forgot the variables. Then I would put a meets expectations sticker, and you would have a 7 out of 10. But you're gonna have a chance to fix that. So then you scroll. So what I'll do is I'll put another sticker with what needs fixed. So like I said, maybe you forgot the units. So by the where you wrote your answer, I'm going to put a sticker that says answer units. Now that's clear, but sometimes it's not perfectly clear, especially when I give you an equation setup sticker, because then you're like, well, is it the wrong equation? Did I set it up wrong? So if you're ever not sure, so the idea is that you look first, and maybe you see the problem, but and maybe you don't. So if you don't see it, you definitely want to message me and we can talk about what's going on. I just need you to be specific about the problem, maybe even screenshot it if you want a real quick response. If you see a signs sticker, then there's a negative, or you have a negative where you shouldn't, or you have a positive where you shouldn't, that kind of thing. Logical flow, I couldn't follow what you were doing. And I'm going to show you how to logically do these so that it's real easy to tell that you know the problem. Sometimes you guys work ahead and I'll just sticker it future problem. That just means you have to resubmit it later. Example problem. Sometimes you guys try to do there's teacher slides where I'll do the problem and I'll have it worked out. And sometimes you try to do it on that slide. You try to submit that slide and I'll just put, hey, that's an example problem. Uh, but anyway, ultimately, and then once you fix it, then I'll put a fixed expectations, and then that'll bump your 7 up to a 10 out of 10. And same thing with needs improvement. You get a 4 out of 10, but once you fix it, then I'll say, hey, you fixed the improvement, and now you got another 6, so you got a 10 out of 10. Again, ask questions if you're unsure. I'm just doing a quick little sticker like, hey, there's a problem here. Look at it again. And if you look at it again and you're not sure, obviously ask me for help. The hand button, make sure you submit slides again with that green, well, the outline of the hand, and then you hit the green one. The 4 squares up on the left-hand side of the screen, there's like 4 squares. If you hit that, that'll show you all the slides, and you can kind of scroll through and see where you have 10s out of 10s. It doesn't tell you your overall score, but it does tell you individually each slide score. So you're looking for 10 out of 10 on slides that are worth points. The example slides aren't worth any points. So just keep that in mind. Some slides aren't worth any points, but it'll say it's out of 10. The squiggle line, when I put a sticker on your slide, it will cover some of your work. Or if I leave a note for you, it might cover some of your work. So right beside the hand is a little squiggle symbol. You click that and it'll clear the screen of anything that I've done on your slide. Now, if I've done it on the edit slide, that's me. That's permanent. That's not going anywhere. But if I wrote just on your individual slide, especially the stickers, you can clear those out so you can actually see the problem. Uh, Again, class problem slide, the one labeled teacher slides, there's a video of me doing them, and then I'll have it written out on the slide for you ready to go. And then, so the equation sheet, this is the last little thing. You'll have access to this on Canvas. So there's an equation sheet with all the equations, and then there's, on the note sheet are just the equations you need for this unit. It's up to you which one you find easier, either way. But I will say the note slides will be specific to the unit, while the equation sheet is all of physics. So on that note, you have to use the equations I've given you. There are rewritten versions of it, different variations of it, but the ones that how I wrote them on the equation sheet, how I wrote them on the note sheet, you have to do it that way. Uh, I don't want variations that we didn't talk about. If you find a variation that you prefer over my way, we just need to have a conversation on why you prefer it that way. And then the conversions. Uh, for this unit, you have to write out how you do the conversions. After this unit, you do not have to write out anything. You can have Google convert it. I'm not gonna, obviously I'm not standing over you watching you do it. I just want to know for this unit that you can do it, and then after that, whatever you find more convenient is up to you. Now for this unit though, you have to use the conversions I gave you on that sheet. So if you hit me with a conversion that I didn't specify in my sheet, I'm gonna kick it back to you that it needs fixed. Even though the answer is correct, I want to make sure you know how to do it with what I've given you. All right. I was a little winded. All right, slide 3. So this is a teacher problem slide. Um, the um, so like I said, and I already said this the beginning part. So read over this, but there'll be a video that accompanies this problem, and then you're just submitting it, acknowledging that you read this. Again, be careful with AI. Ask it to explain it. Don't let it tell you the answer. And I cannot stress this enough. It will do it in different ways. So you need to make sure that the way it shows you is the way I showed you, or you need to translate it. Sometimes it just will not do it the way I showed you. I'm showing you in a way that is very easy for me to tell that you know what you're doing. AI doesn't always do that. AI will just give you the answer the way it thinks is the easiest way to do it, which doesn't always agree with what I think. So just be cautious of that. I'm not going to take it. If it has to be similar to how we've discussed it in class. Again, if you find an alternative way that you find easier, we need to have a discussion on why you think it's easier, and you need to show me that you understand it that way. All right. So for the class problems, this again, I'm going to write this one out. Oh, sorry, trying to get a pen here. All right, and then so I'm going to walk you through this. So these are conversions, and we don't. They pop up. They pop up here and there. Probably a few times a chapter. Just depends on the chapter. But what happens is they will. We're going to use the metric system. Sometimes the problem is given in our system with like feet or inches, and the metric system needs it in meters. So there's a situation where you would have to convert. The other reason I'm throwing conversions at you is we don't, a lot of us, not everybody, but if you grew up in the US, you don't recognize the metric system. Like I could tell you I'm 10 or yeah, 3 meters away from you. It doesn't, you can probably recognize that a meter's around a yard, but that again, that's not like something that just pops in your head. Oh, I can picture how far away you are. Or speed. If I tell you I'm going 70 kilometers per hour, that sounds fast, but it's 40 miles per hour. So it's not that fast. So a lot of the times we're converting so we can visualize things. Physics is hands-on, concrete, like you can visualize it, a lot of it. So this first example we're going to do is, would you rather lift 100 pounds or 100 newtons? Now, newtons are the force unit for the metric system. So it's equivalent to pounds. It's the metric equivalent of pounds. We don't use newtons. So when I tell you something weighs 100 newtons, you're like, I don't know. Is that more than 100 pounds or less than 100 pounds? So what we're going to do is we're going to convert, and then I kind of wrote it out for you. When I didn't write it out for you, but I specified how I wanted you to convert. You're going to convert newtons to pounds. We could convert pounds to newtons and still answer this question. I'm just picking this way so that we're all on the same page doing the same similar thing. All right, so I want to convert newtons. So I'm going to start with 100 newtons. That goes in this first box right here. And then these are called train tracks. If you had chemistry, you've done a lot of these. If you've never had chemistry, this is the first time you're seeing this. So I'm going to go slow. Watch the video again. Ask me questions if you're getting stuck, but it's the same process every time. You put what you want to convert in that top box. So in this case, we want to convert 100 newtons. Now, I want newtons to cancel out. So the only way stuff cancels out in math is if you divide it out. So newtons has to go down here. Now, I'm not writing any numbers yet. I'm just setting up my units. I need newtons. The only way, like 2 divided by 2 is 1. Those cancel. 100 divided by 100, right? Cancels to 1. as weird as it sounds, newtons divided by newtons is going to cancel to 1 and it goes away. What I want though is pounds. Now, sometimes we can't go directly to what we want, so we might have a couple extra tracks like I drew on the slide here. This time, it turns out we're not going to need them, but because I did give you a conversion for newtons to pounds. And then this is where the conversions come in. They're on the note sheet, they're on the equation sheet, but for now, you got to use mine. After this unit, use whatever you want. So, and on my sheet, it would tell you that there are 0.225 newtons in a pound. 0.225 pounds in a newton. Sorry, I did that backwards. 0.225 pounds. Almost messed up the problem. There's 0.225 pounds in a newton. And then that's not something you have to memorize. You would just look that up. And for now, you would look it up on my equation sheet or the note sheet. Later on, look it up online. All right, so now what we're going to do, this is where the calculator comes in. We are going to multiply everything on the top, and we're going to divide everything on the bottom. So dividing by 1, we don't have to do that. If there was a number there, then you would divide by that number. I'm just going to do 100 times 0.225. Now, some of us, if you're decent in math, you've recognized 100, you just move it over 2 places. If you had to use the calculator, not a big deal. Whatever you need to do to solve this problem, 22.5 pounds. And then we will be talking about significant figures if we haven't already. I'm only gonna I give the answers using significant figures, but I'm not gonna stress them where you have to give the answers. So if you wrote down 22.5 for this right now, I'm okay. Significant figure wise though, right? 100 newtons, there is no decimal. So this only has 1 sig fig. So our answer technically should only have 1 significant digit. So that's 20 pounds. So 100, it's around 100 newtons, so it's around 22, or I'm sorry, so it's around 20 pounds. I'm not going to be that picky about it. Labs is when we need to worry about sig figs, so we'll stress it in the labs. Practice wise, I'd like you to keep it in the back of your head, but I'm not going to take points away from you. But that's the gist of this one. I'm going to show you one more. All right, so then you're going to try this one on your own, try this one on your own. And then here's one more teacher problem. This is 11 meters per second. So now the question is, well, what? I got 2 units. Should I do them separately in 2 tracks? I'd prefer you didn't. I'm going to show you how to do it in 1 track, and we're going to convert, like it says, meters per second to miles per hour. We could have done it the other way. Doesn't matter. This is one of those instances where you got an answer in the metric system, and I'm like, I'll have you convert it to our system so you can actually visualize it. Oh, so that last question real quick. Sorry. So which one would you rather lift? 100 pounds versus 20 pounds, right? So that's either way. But that's why we're doing those conversions so we can actually compare and see how close they actually are or aren't in that case. All right, so what is faster? 11 meters per second. You can actually do this in the same track. You're going to put meters on top, and instead of writing meters slash seconds that way like they did, you're going to write it this way. You're going to put the seconds underneath. Now, if it bothers you that there's not a number by that seconds, it's really 1. It's 11 meters every 1 second. You don't have to put the number there, but if you like it, that's up to you. And then you can start by converting meters to miles or seconds to hours. It doesn't matter. I just usually start with the top one, and I'm going to put meters down here. What I want is meters to miles. Again, I didn't put any numbers yet because I'm going to look those up on my conversion chart. And then I'm going to look somewhere, hopefully on that conversion chart, and it's on there. I'm not going to give you anything that's not on there. There are 1609 meters, 1,609 meters in a mile, which some of you, if you run track ever, or in gym you did you had to run the mile. It was 4 times around the track. 1 time around the track is 400 meters. 4 times around the track is 1,600 meters. Now you're 9 meters short of an actual mile. I don't know if they made you run further. Who knows? At a track meet, you're running the 1,600 meter. You're not really running a mile, but it's close enough, right? All right. So meters. What happens is I just canceled out those meters, so the meters are gone. So now I got miles per second, but I don't want miles per second. I want miles per hour. So I need to take care of that seconds I want to take care of this now. So seconds goes up here. Now I can go seconds to minutes, minutes to hours. We know there's 60 seconds in a minute and 60 minutes in an hour. That's going to be the same thing. That's going to happen every single time. So I'm going to do a little shortcut for you. 60 times 60 is 3,600. There's 3,600 seconds in 1 hour. And then it just saves you some time. But you seconds to minutes, minutes to hours, if you want to do it that way, is also fine. All right, so the seconds. So how did I know to put seconds up top here? Well, because seconds was down in the denominator, and the only way things cancel out is if one's above the other. So they have to be one, they can't be on the same track. They have to be one above the other. So meters was on top, meters was on the bottom, they cancel. Seconds was on the bottom, seconds was on top, those cancel. And then what I'm left with is miles per hour. That's right. I got miles here and hours here. So when I go to write this answer out, this is where you grab your calculator, Desmos, whatever you're using. Sorry, I need to open mine real quick. And then I would do everything across the top is multiplied. Everything along the bottom is divided. So I would do 11 times 3,600 divided by 1609. And I'm going to get 24.6. 24.6 miles per hour. Now, if you wrote that, I'm fine. I'm not going to mess with you. Sig fig wise, 11 meters per second was 2 sig figs. And again, we'll review sig figs and all that. And again, I'm just going to stress them in labs. Here, we're just practicing them. So if you gloss over them, it's not the end of the world. And then here, that's just my way of telling you I'm going down with this answer. So 24.6 has 3 sig figs. To get 2, I would round it to 2. All right, guys, so try the rest of these. You're going to try on your own. And obviously message me if you get stuck.